Okay, hi everyone. I think we're going to get started. So just to do some quick introductions, my name's David Carter, and this is my colleague.
I'm Matt Tester, and from the name, I'm a developer, obviously. So
Never gets old that way.
no, every time.
So we're from a company called Stratus Technology Partners down in Christchurch. We build all sorts of custom software solutions. A lot of our work's in the medical field, and that's what we're going to talk about today. So our story starts in about May last year, where we were invited to do a tender for a large Australian health project. And the client was Crohn's colitis cure. And this is a foundation that's looking to find a cure for two really nasty, debilitating conditions called Crohn's disease and ulcerative colitis. And they affect hundreds of thousands of Australians and New Zealanders are affected by this. So what they wanted to do is build a research database, the largest of its sort in the world, and get as much data as they could on people suffering from these conditions. So the interesting thing is the way they wanted to get data into that research database is by building a great clinical management system as well. So what they'd have is gastroenterologists using this clinical management system to record patients' data, which would then be transferred to the research database. So that's how they were going to capture this huge data set. So that was basically the challenge. How do we build this clinical system that's compelling to use and is secure? And how do we build this research database? So we won the tender, which was really gratifying because we were up against all sorts of Australian and European and American companies. And the original concept was that this was going to be deployed on site at medical locations and hospitals around Australia. Now, I don't know how many of you are from hospital IT departments, if anyone? Yeah? So you guys know that you're pretty much under-resourced, and the last thing you want is third-party vendors coming along, knocking on your door, saying, please, can you install SQL Server 2016, IS 8, and I need you to patch this. It was just really high risk if we were going to be engaging with multiple hospital IT departments. So I went to the client and I said, look, I think this is a really big risk. We need to try and mitigate this. How about we do it in Azure? And as it turns out, all our ducks were lining up at that, around that time, and Azure just had, Microsoft had just announced that they were going to be having data centers in Australia, etc. So it was really good timing.
So what are we going to cover? First off, we need to be able to authenticate users, the clinicians that are going to be using the application. So we'll cover a little bit about how we used Azure AD to actually set that up, and some of the other features within Azure around that as well.
So patient confidentiality is obviously your top concern when you're building a medical application. There's data in there that you really don't want leaking out. So we had to look at things like how we protect against attack and intrusion, including secure authentication, transport, data encryption, multi-tenancy, all those sort of things you have to take into account. So we're going to show you how we use some of the latest features of Azure and SQL Server 2016 to cover those concerns. We also needed to provide a great user experience. That was the part about building a great clinical system. So users of the system are going to be clinicians, and they're very time poor. So the system has to be quick, it has to be responsive, it has to do what they want. And this is one of the challenges of building medical systems, is that they're complex domains, right? Gastroenterology is really complex. And the whole team spent the last year basically learning how to be amateur gastroenterologists. And we haven't had to get our hands dirty yet, thank goodness, but it's been quite a learning curve. We'll show you how we built, or we used a couple of tools, mainly Formly and Hangfire, in order to build a great user experience.
So we'll have a look at the architecture, just to give a bit of context about what we're actually talking about here. But first up, our first question was going to be, why can't we host on Azure? We do lots of projects, and we use Azure for that, but we hadn't done something that had these security requirements around it. So we had to have a look at the security story that was in Azure. So we were able to use the new features within SQL Azure, which is the same as SQL Server 2016, things like Key Vault and Azure AD, and pull those into play as well. So actually had a really good security story that we could leverage.
So happily, around this time, I guess in the last year, attitudes have been changing towards storing data in Azure and using applications in Azure at the government, health, across all the levels. I think 2 years ago, we wouldn't have had a show of getting this going. but now we do with those changing attitudes. So Microsoft have been a great partner to work with, and I'm not just saying that because we're at Ignite, but they really have. I've spoken to so many people, technical, sales, directors, who've all been totally behind the project and given us their time. They've also got a great track record in Australia with health projects, so that helps smooth the path.
So looking at the big picture, we've got two parts to the system. We've got the clinical system and the research system. The clinical system being the aggregation of the data for use in the research side of things. So right at the top there on the left, we've got a clinic application and a patient portal. Both of those are Angular applications talking to individual web APIs using OAuth. So for clinicians, we're using Active Directory to authenticate those guys. And on the patient portal, we're using ASP.NET Identity.
So this was another interesting learning for us, was the idea of a patient portal, because we hadn't originally actually envisaged having one. But when we spoke to Microsoft and they reviewed the architecture we had, they went, well, you've got a problem here. You can't send the emails you want to with the information you want in them to patients. So it has to pass the MAL test. Do you like the MAL test? I haven't heard of that one. So apparently the MAL test is a patient should be able to print off an email, leave it lying in the food court at the mall. Someone should be able to come along, pick it up, and be no wiser as to their condition or what's wrong with them. So that meant effectively we had to build a portal, and then we could just send out a vanilla email which says, hey, you've got stuff you need to do, go log into the portal and see what you need to do. So so the MAL test, if you're building medical applications, that's a good one.
So notice that both the clinical application and the patient portal both talk to the same database. So this database is essentially a multi-tenanted system. The clinicians should only be able to see the patients that are in their health center, and the patients should certainly only have access to their own information. So we'll go into a little bit of detail about how we're able to use the SQL Azure, or basically the SQL Server 2016 features to actually secure that database and keep everything safe. So on a regular basis, information is going to get sucked across over into the research system side of things. It says on the diagram there SQL Data Sync, but that's probably the longest running preview in the history of Azure and hasn't made it out of preview yet. There is something called Data Factory, but we actually opted to use SSIS and BIML scripts to do that, hosted in a VM. So there's actually a session after this over on the Crown Plaza from Simon Peck, talking a little bit in detail about how that can be done.
And Simon's actually consulting with us on this project, so yeah, I think it's worth seeing. You'll also notice that we've got Power BI up in the top right there. So that's how the users or the researchers are going to consume the data. If you've worked with researchers, you know that they like Excel. They can't live without it. So we're going to be giving them access through Power Query to actually do that. But then there's other stakeholders who want to see top-level data and pretty graphs and that sort of thing. So we're going to expose that and content packs through Power BI.
So one thing to mention as well, when the data moves across from the clinical system to the research system, it's actually non-identifiable information. That's why we have that separation as well. The researchers need to be able to free to query that data. So when the data is moved across, there's no PII, no patient identifiable information comes across.
So with regards to authentication, we decided to go with Azure Active Directory. I've already heard it mentioned a couple of times, security as a service. It's a bit of a buzzword at the moment. And for what we're doing here, it makes perfect sense. Microsoft have got these security teams who look after the bad people and make sure that their security practices are up to date, all that sort of stuff. You can turn on multi-factor authentication, etc. So we really didn't want to have to do all of that, so we're just using Office 365 and Azure AD to authenticate.
So what we'll run through is just how you set that up within a SPA application, a single-page application. So just set and scene here, we have our web app, our Angular app, and in this case it's going to be the clinical system. We have our web app down the bottom with our API deployed to it, which is wanting to talk to the database. So in Azure Active Directory, we've got these two things defined, a web and an API. So who's used OAuth before? And who has to look at the docs every time they're using OAuth because it doesn't make sense? Exactly, they're the same, right? So we have two apps defined. Now why do we do that? So I heard it described this morning as the OAuth dance. So when you're trying to get a token, an access token, identifying who you are, you've got to do the OAuth dance. You've got to have a series of requests coming backwards and forwards. Now the OAuth dance, you're sending your client ID up and your client secret to the identity provider, in this case Active Directory, and it's going to give you back a token that you can use to identify yourself. With a SPA, a single page application, we can't hold secrets. People look at the JavaScript code, people look at the traffic coming across. It's a lot more open. So you actually have to do a different OAuth dance. So what we've got here in Azure Active Directory, we have our web set up with implicit grant flow. So that's just a way of being granted a token that is in a way that is designed to work with single page applications. If you've authenticated with the web app, then we've said that you are also allowed to access the API. So when our web app is trying to authenticate a user, we're authenticating and saying, can we have a token for this user? Now, to help us with this process of redirecting the user and knowing when to do that, there is something called the Active Directory Authentication Library, which is written by Microsoft. And there is a handily, a wrapper for Angular as well. With this library, we can set up our app and say which pages within our single page application should be secured, which you should have an authenticated user for. And this library will do the redirection for us. So once we've set it up and said, this is the app that you are, please go and authenticate with Azure AD, it will kick in for us and redirect the user to AD for them to log in. Once they go through that process, the token is sent back down, and this library handles the storage of that for us within our app. So in that sense, it's quite seamless to us. So that when we go and make our request to the API, it's actually sending the token as well, which the API can then verify with AD and say, am I actually able to use this and trust this person, the identity I've just been sent, and then it can use that to call the database. So again, the ADAR library really helps us here. We actually just set it up and say, whenever you call this API, I want you to send the token that you have at the moment to the API for us. So within our Angular app, we're just making our call to the API as we normally would. We don't have to do anything special. And the ADAR library kicks in and passes that token along for us. So it's not all roses. The ADAR library has been a little bit flaky in the past, and there have been constant updates to it. But it does help with a lot of those things, the grunt work that would be required to do the OAuth side of things. And it does the refresh side of things as well. So if you're idle on the application for a long time and your token has expired, as long as the refresh token hasn't timed out yet, it will silently re-authenticate you with AD and give you a new access token to go and be able to access the API quite seamlessly to you. We certainly don't have to do any extra work for that. So now that we've identified the clinician, when we're actually calling the API, we're now sending that through to the database.
So the gods were smiling on us, and SQL Server 2016 had just been released a little bit before we started this project, and it had a whole lot of great new security features that we wanted to use. It had row-level security, data masking, encryption at rest, and more recently, AD authentication. So we just want to have a look at those. So with AD authentication, this is relatively new. I just started playing with this about a month ago. But from a DevOps perspective, this is awesome. Effectively, you can control logins to a database through your Azure Active Directory. You don't have to create logins on your database instance anymore. So, I mean, it really is as easy as basically setting up someone in AD. You can even do it at the group level, so you can set up a group in AD, and then you just execute that bit of SQL there, create user, group name from external provider, and bang. You obviously have to assign the necessary rights to the user or group as well, but it really is that easy. And one of the things we've discovered in this project as well is something called ISO 27000. I don't know who's had to deal with ISO 27000. Does anyone here do ISO 27000? Yeah, the rest of you lucky buggers. So that's really, it's got ISO 27000 standards all about information and data protection. And it's not just about technical practices, it's about all the other stuff. So you have to have documentation to show that what your processes are if someone needs access to a database, what you do when you hire people, they leave, etc. So all this stuff really helps with that, because we can show documentation-wise that we can add someone to a group in Active Directory. When they leave, they get taken out and they can no longer access the database. So that's, from a DevOps perspective, that's been really valuable. So, right, what's the next one? Row level security?
Yep.
Okay, so row level security. In the past, when you wanted to do multi-tenancy in a database, like we do in this one, i.e. we have different medical centers and we want the data siloed, so a doctor in this medical center can't see the patients in this medical center. That's what we're referring to when we say multi-tenancy. In the past, when you wanted to do this as a developer, it was a real PIA. It was difficult, right? You needed to either use stored procedures, or you needed to have different database users or views, or fiddle with DB contexts, or ensure you had a where clause whenever you queried the database, stuff like that. But thanks to row-level security, you don't need to do that anymore. So what you can do, right, is define your multi-tenanted rules, i.e. how the data is segregated, at the database level, right in the database engine, essentially. So if you query it through Management Studio, it gets applied. When your app calls it, it gets applied. So that means that you can write it once, you can get it right, and you don't have to worry about data bleeding from then on. You don't have to worry about the new developer who's come on board and forgotten to add a where clause, any of that sort of stuff. And when there is legal implications to what you're doing, it's actually quite important that you get that right. So I'm going to be able to sleep better at night knowing that we've got row-level security.
So what we're looking at here is a security policy that's been defined. It's just been called patient's policy. And what we have here are two predicates, a filter predicate and a block predicate. So the filter predicate is about which rows should be available for selection for a particular user, and a block predicate is what's the condition that should be met when a row has been updated or inserted into the database, into that table. So these two predicates here are both being applied to the patient table, patients being the schema, patients.patient. So a table can only belong to one particular policy, and so it can only have at most these two predicates. The predicate is actually just going to be a function. So right there, we've got a function defined as filtered by medical center ID. And it's been given a parameter of medical center ID, which is actually coming from the patient table. So what this is doing is whenever we're querying from the patient table, it's actually applying this predicate for every row. So when you're querying that table, that is going to be applied and determine whether you actually see any results or not.
So a couple of things here. It's a good idea to keep your security functions in a separate schema and to really control who has access to that schema, because if anyone can turn off the security functions, well, they're not very secure. So you need to think about that. Also, because this gets run with every query, you need to make sure it's performance. So you've got to make sure your indexes are right and you don't have a bunch of different joins across it.
So let's just have a quick look at what that function actually looks like. So it looks like a normal function with a little caveat that it's actually returning a table. But the way it's been defined, it's actually an inline table, and that's for that performance side of things. So because it's an inline table, it's basically returning something straight away. There's no function body. SQL has the opportunity to actually optimize this, so it's not as expensive as it might sound at first. So in that select there, ultimately, if this function returns a table that has a record, it doesn't matter what that record is, it means that that row is available to the user. If not, then it's not going to show or not going to apply. So that's the true and false of the predicate. So there where we're saying select one as filter result, it doesn't really matter what you put in there. That's just what's going to return. So what we're doing here is we're saying we've been given a medical center ID, and we're trying to work out if the current calling user is a member of that medical center ID. So however we need to determine that in the database, we have a medical center ID aligned with the user on the user table. So how do we know the current user? So you see there we've got this session context. So whenever we make a call through our entity framework, DB context, we have the opportunity to actually add a little bit of metadata. So we call a secured store procedure that is going to add some things into the session context for us. So we know who the user is, we know who the clinician is, and we've worked out what their user ID is when they've logged in. So that when we're actually calling the database, we're setting something on this session context, which is just a dictionary, of their user ID. And so when we want to use these security functions, we can read it out and actually apply it. So we know who the current user is. So if I go into Management Studio and start selecting from this database, that's why I don't see any records. I'll see nothing because I haven't actually said anything in the session context about who I am. And that will actually trip you up in development. You look at your database and you look at your tables and you say, I've got no records. Where did all my records go? you just forgot that you had the security policy applied.
Yeah, it happens at least once a day.
Yes.
I think it's also important to note here that we use database projects for defining our databases. And that means that all this sort of information is stored and versioned in our version control system as well. So that's a really nice side effect as well.
Okay.
Cool. All right. So dynamic data masking. So what is that? Well, essentially, dynamic data masking gives you the ability to mask characters in a field. So you can go into your database and you can find your PII fields, you know, your patient identifiable stuff, your first name, last name, email, address, all that sort of stuff. And you can say, I want them to be masked. So there's some examples of masking there. You know, there's a whole bunch of default functions you can use. So email gives you, you know, the funky.com, and there's credit card ones and all that sort of stuff. So why did we want to do this? What it means is that we can have DBAs or developers look at the production data, and if they don't have that unmask function, they're not going to be able to see any PII. So if we're trying to debug an issue on a live database, we just make sure the user doesn't have the unmask function and they can't see any PII information, which is really valuable. Once again, it's done at the database level, so it gives us that security. And also, we make sure that when we do the ETL process, the extract, transform, load from the clinical system to the research system, that user that does that ETL doesn't have the unmask function. So any PII data that goes across the research database by mistake shouldn't happen, but if it did, it's just another safety net. It'll go across as X's, essentially.
So it's worth pointing out that it's not actually changing how the data is stored, it's just changing how it's read out. So if you don't have that unmasked privilege, you're going to be reading out the masked value. So it could happen that you're reading the data out, and it's the email address, and it's xxx.com. Great, it's all masked. But if you go and update that record and send that data back down, it's going to store the masked value. So then when you go, oh, I made a mistake, I need the unmasked privilege, I should be able to see the real value, you'll still see the masked value because you've just written it back over that record. Ask me how I know.
Cool. So transparent data encryption, this is another great feature. So we went a little bit over the top, I think, in security. There's no clear rules about what you need to do to secure a medical system, right? There's suggestions and things, but we wanted to try to do everything we could. And we wanted to make sure that all the files at rest were encrypted. So what's a file at rest? Essentially, it's anything written to disk. So your database files in a system like this, all your letters and reports from patients and clinicians, etc. Everywhere that essentially that data is stored, it needs to be protected. So if you've done this before in SQL Server 2014, older versions, etc., it's a real pain. Wouldn't it be nice if there was just a box you could tick in Azure? And it turns out that there is, and you can actually see it happening there. So essentially, to get this to happen, all we had to do is go into Azure, tick a box, we've got an encrypted database file. So that's a really cool feature. One of the things that Azure SQL doesn't support is file streams. And we use file streams in other developments to store large files in SQL Server. So, you know, file streaming works by essentially writing a file to disk and keeping a pointer in SQL Server to that, but it also backs it up and does all that sort of stuff. So we had to work out how we were going to encrypt these files that we were storing, not in SQL Server, in blob storage. So any letter, any document goes to blob storage. We need to work out how we're going to encrypt those and keep them safe in blob storage.
So we'll run through that scenario now. So we have a file being uploaded to our web app, and then we're going to pull in a few pieces from Azure. So we've got AD, Key Vault, and blob storage. Now Key Vault is the crucial bit here. That's the secure storage of keys and secrets. And in our case, it's going to be a certificate for encryption. So Key Vault sounds like it stores the key, and then when you ask for it, it'll give you the key. But if you think about it, if it just gave you the key, then it's lost control of that key. It doesn't know what's going to happen to it. It's lost any traceability about it. So what it actually does is does the encryption for you. So in order to be able to control that key, you've got to control access to it. So we need to know who is allowed to use these particular keys to encrypt or decrypt. So we actually have to get a token to identify an actual application. So first job, we need to authenticate our application. So we're authenticating who the caller is, which is the app, not the user. It's nothing to do with users right here. So when we've created our key within Key Vault, we said this web app is actually allowed to use a particular key. So we need to encrypt something using this key. So we're going to go to Key Vault and say, I need some kind of key reference so that I can encrypt this value, and it gets that back. Now, this key reference is actually just a reference to the API. And with it, what we do is we just say, I've got some bytes, uses the key reference to call Key Vault and says, here are all my bytes, can I please have the encrypted bytes back? So by the time we actually get the file into blob storage, all the data has already been encrypted for us through the Key Vault. So the benefit of this is that we have these secure keys held for us. They're auditable. We know that they're in there, and they know that they can't be retrieved and lost somewhere else. So obviously, when we want to decrypt the file and send it back down to the user, we do a bit of the reverse process. So we know the file that's been requested, so we pull that file out. So we pulled the file out, but now we need to know which key to use to decrypt it. So the metadata on the blob storage says which key was used to encrypt this particular file, and it says which version as well. And this is all handled for us within the SDK. So the reason for that is that keys can cycle. You can cycle your keys and say, okay, I've got a key called blob encryption, and it's version 1 initially. You can say, I want to generate a new key. I want a version 2, a version 3, a version 4. So all new things will be encrypted with version 4, but you might have an old file that you're trying to pull out with version 1. And that's why the metadata on the blob storage is actually important. So first step, we read the file out so that we know what key we need to use to decrypt these bytes. We identify who we are again, and then we'll go over to the Key Vault and say, can I have a reference to that key? And I'm going to call the decrypt function, basically. Decrypt these bytes, and then I'll have the decrypted bytes to send back down to the user.
So that's awesome, and it works really, really well. But wouldn't it be nice if there was a button like for the encrypted database that you could just tick in Azure? Well, it turns out that they went and put one on a couple of weeks ago. So you can largely disregard most of that. No, when we were doing the talk, we were like, well, let's try to find out why it would be better to do it our way. Let's have a good think about this. Surely there's got to be some advantage to the way we're doing it. And we came up with one, which is this, the way that Azure does it now with the tick box makes it transparent. So if you can see the file, you can read the file. The way we're doing it, you can still have access to a container, but the files are still encrypted. So once again, from a DevOps perspective, if someone wants to go in and move files or archive them or delete them or something, you can separate that security so that they can't actually read the files, but they can just work with them. Whether that's actually a valid one or not, that's consideration.
So regardless of that as well, even if you're using Key Vault, the action is the same. You need to identify the caller to Key Vault. So you'd still need, forget about the blob storage at the bottom, you still need to identify who the caller is and say, do they have access to the key to get that reference to encrypt or decrypt files. So that part of the process is still exactly the same. And even though it looks a little bit complicated, the SDK is actually rather quite good. Asks you to fill in a few details, implement a few methods about authentication and things like that. But until you break it down into this diagram, it's actually quite helpful to see what it's actually trying to achieve, because otherwise it just says, I'll do this. I don't know why I'm doing that, but I'm doing it anyway. So it's a good understanding. But yeah, notice that we have to actually proxy everything through our web app itself to go and get the actual file. So if you've used blob storage for things that don't need to be encrypted, you can use those shared access tokens to have the client, in our case the Angular app, give a reference directly to blob storage and the file gets streamed from blob storage. We can't do that through this manual process of managing keys, because we have to do the decryption. It's us that has access to the key. With the transparent data encryption, you probably could. I haven't tried it, but that's the whole point of the transparent side of things. You don't know that the blob files are encrypted. You just put a file on there, it gets encrypted for you. You pull a file out, it will decrypt it before it gives it to you. You just lost a little bit of that control.
So as I mentioned before, user experience is really important. Now, we wanted to build a SPA, a single-page application, because that's what we do, and we've been doing for the last couple of years, and we love building SPAs. We write more JavaScript now, I think, than we do .NET, which is good and bad points. So we built quite a few projects in Angular. That's our framework of choice. And we've got quite a mature framework and understanding of it now. So one of the issues with having all this encoding of data and encrypting of data and dealing with that is that it takes time, right? So the user uploads a file. You don't want them sitting there for 30 seconds, a minute, waiting for this thing to encrypt, etc. So to keep the app responsive, we use a framework called Hangfire and a pattern of eventual consistency to handle things like that.
Has anyone used Hangfire as a matter of interest or heard of it before? A few people. Okay, so Hangfire is a .NET library, and it's essentially a bit of a message queue. You put things onto this queue, and at some point, things will actually execute. So here we have our application. It's going to be using Hangfire and say, I want to do this task, this particular job, call this method at some point. Hangfire will then write that information down into the database or whatever it's set up as its queue. And then there's the other side of Hangfire, which is the Hangfire server, which is actually just a background process. So in this instance, we have our web app, and in the startup CS, we've actually said, hey, Hangfire, can you run a service process within this web app? And it is going to then go and read from the queue and pull that information out and execute it whenever you want. So you can have them in the same app domain like we have here, but there's actually no limit. You can actually separate that out, and that's what we've done. So we have our web app completely separate from the Hangfire server. It's writing things using the client part of Hangfire, saying, please do this job in a few minutes. That gets put on the queue. And then we have our web job, which is just a console application, which has been set up to start using Hangfire server, and that's going to go and pull the information off the queue and then go and run it and go and do that work.
So this is, Hangfire is really, really easy to use. And you can use it on-prem or in Azure or wherever you like. So that's one of the advantages over using Azure message queues. We've written this in a way that we could potentially move to Azure message queues if we needed to, but Hangfire works really well for us. It's also got one of the advantages is that because we use the encrypted database as the queue essentially for its jobs, any files that are going to be encrypted are stored in that encrypted database. So all the message queue is encrypted just by virtue of the fact that it's in that database. So that just gives us another layer of security, which you can't actually get, I don't think, with Azure message queues at the moment. It doesn't support encryption of data waiting to be processed.
So an example of where we use this is, as Dave said, we're uploading the file. It gets sent up to the API, gets stored in the database, but importantly, the response comes back to the client. As far as the client's concerned, the file is all there and it's all stored and encrypted. Well, actually, as Dave said, it is encrypted. It's in the database, just temporarily. It's just as a big blob storage, bytes stored in the database. So then at some point in the future, the Hangfire process can kick in, pull that file out of the database just as a byte stream, and then actually store it properly on disk. So we're saving a bit of disk space now in the database. Once it's done that, it will mark that job as complete, but we can still actually see it. We can replay it if we want to, if there is any particular problem. If that process failed, I mean, when we're doing our encryption, we're hitting a few different services here. If there's a failure at any point there, then the job will actually fail as well, and it will automatically retry, or we can manually retry it as well. So this is our eventual consistency. Things will progress, and we will actually be able to recover.
Okay, so Angular formally, right. As I mentioned, we do a lot of Angular work. Now this project, because of the research component, was going to need to have a lot of data captured. If you know researchers, you know they like to capture data on everything, because when you're looking for a correlation, you don't know what's going to cause it, so you just try to capture the world. So we knew there were going to be dozens and dozens of forms. And no one likes writing forms, right? It's just, especially if you're using Bootstrap and using responsive framework, there's just screeds of HTML with little input boxes stuck around. So we wanted to make it really easy to define and work with forms. So we had a good look around, and we came across Angular formally.
So formally takes the approach of less HTML in favor of JavaScript. So what do we mean by this? When you've got a form and you're creating a form, you're ultimately working on a model. When you hit that send button or save button, whatever the fields have been shown in the HTML, you're going to send that data up to the server. And what formally does is it just asks you to define that model in JSON. So right here we have a key surname. So we're saying we want a property on our model called surname. It's going to be of type text, so this will say to formally use your text renderer, so it'll be a text box, whatever we've configured it to be. And we've got some template options. Maybe we want our label to be surname. So again, the templating engine can kick in and actually put the label surname above that field. Taking it a little further, we've got title ID here. So anything ending ID is basically a foreign key. So we have titles, Mr., Mrs., Miss. So we have type lookup. That's going to be a lookup list. It's going to hook into our lookup system. And using the lookup name there defined in the template options, it's going to go and look for the title lookup list. And again, put a label at the top called title. So we're repeating ourselves quite a lot here. Titles everywhere. On the previous one, surnames everywhere. The field is called surname, the label's called surname. So we could actually condense that a little bit. So what we actually did was we extended formally a little bit and we created some conventions. In our example here, we said that if a field ends in ID, then maybe the first part is going to be the lookup name. So in this case, it is true. Lookup name is going to be title. Our default fallback might be text. So if we have a key and it doesn't have ID at the end, like surname, maybe we should always render it as text. So ultimately, we can actually define a model for a form as succinctly as that, and the defaults will kick in a lot of the time, 9 times out of 10. So there we have title, doctor, that's a lookup list. First name, surname as text boxes. Email there, so we can use the email type, HTML5 email type, when it sees the email is present in the key name. So we've built up a lot of these conventions that we can use throughout the system, and certainly with the lookups, it saves a lot of time and keeps things really responsive and consistent as we go through.
Yeah, so it's given us tremendous code reuse, and we can knock out forms very, very quickly now, which has certainly saved us a lot of effort. But it's had another interesting side effect. Some of the forms that we do are forms where you're applying for funding for a particular drug or something like that. And it's almost a legal document. So you really need to capture what the user entered at that time, and you also want to capture what the form looked like at that time. So what we do is we actually store the captured information as a JSON object with all the information in, and we store the definition of the form at the time as well. So we've actually got the definition stored and we've got the data stored, and when we need to, we can munge the two together. But those two aren't going to be affected by any database upgrades you do or schema changes or anything like that. So it really works well as an audit trail of what the user did at that time and what the data was.
So formally is just taking those items there and running it through the templating that it's been configured with. So we've configured it to use Bootstrap, and obviously we've customized that a little bit. It looks a bit more material design here, but it doesn't really matter for our application form scenario there. We know what that form actually looked like, and it doesn't matter what the templating has changed to in the future. It's still going to render pretty well.
Yeah, I think we've actually got another layer of abstraction underneath, which is directives in Angular. So directives are great for being able to specify bits of common code, and we actually use those as the templates for each of these. So we've got a lot of control the whole way down the stack as to how we render forms. So just to have a look at a summary of what we covered. So we had a look at how to authenticate users. Like we say, we use Azure Active Directory. Fantastic. It's been really good to work with. Would recommend the Adele library, but just be warned, you're going to spend some time on it. Put a week aside to get that in because, yeah, it's a little bit fiddly.
Also covered how to protect sensitive data. Basically, the rule is encrypt everything, encrypt, encrypt, encrypt. Azure SQL Server 2016 has lots of great features that are worth using. And the Azure Key Vault, like we said, our scenario might be obsolete with some of the transparent data encryption, but if you are wanting to encrypt things in a queue, right now there is no transparent data encryption. So you would need to use the process we showed there to actually encrypt things using Key Vault there anyway.
Maintaining a great user experience. So we talked about handling those long-running tasks asynchronously. And Hangfire is a great way to do that, obviously as your message queues as well. And then using a single-page application framework. If you don't do it, it's something you have to have a good think about, depending on the skill set of your developers, etc. It is very different from doing an MVC app or something like that. There is a big learning curve. There's a bunch of frameworks to choose from. We chose Angular because, to be honest, it had the most information on Stack Overflow. And when you're stuck and you're looking for an answer, that's what you want. We're going to be moving to Angular 2. I would say probably at the start of next year, which will be really exciting. So if you're thinking about it, you may want to hang on and wait for Angular 2. I'd probably suggest that at this stage, and boot TypeScript, all that sort of good stuff. But yeah, single-page apps, I think they're the way to go.
So the key takeaways are the tools are there to be able to make a secure app. Especially with Azure, be aware that it's going to change, and you've got to keep up to date. But yeah, definitely the tools are there.
So one of the other things we discovered is that every Australian state is different, and they don't talk to each other, and they don't like each other, and they don't want to do what the other ones do. So make sure that you speak to all the relevant health authorities up front, and you understand what they want, because you ask for their security requirements, framework, infrastructure document, and you will get totally different documents. So be prepared for that pain. It's not easy. But talk to Microsoft. Like I said, they've been a great partner, and they've got guys who can help you out with that. So yeah, so please evaluate our session. If you've got any bad feedback, give it to Matt. I'll take the good feedback. But otherwise, we'll take some questions, if any questions.
Yeah, you've segregated the data from a medical center.
Yeah.
What happens if a patient goes from one medical center to another?
Yeah.
Where they're not involved?
Yeah. So we've got a transfer function in there to do that. So,
So you're going to transfer them. Who's going to run that?
sorry?
Who's going to run that function?
So the question was how would you transfer a patient from one medical center to another? So there are the two predicates there, the filter and the block. So when we had the block predicate, we were saying that this predicate must match before insert or after insert. So that gives you the option to actually say that a patient can be read from your medical center, but when you're writing it back, the block predicate is going to run. So as long as that condition is true before insert or after insert, you have a bit of control there.
So two records of the same patient, different medical centers?
No, that wouldn't. No. It would be actually changing the ID, so the filter predicate would kick in a different way. But you have we can explain afterwards. It's down to that block predicate. That's when the writes are happening. But you have a bit of control about when that actually runs. In the same way that a trigger, you have a bit of control. You can say after insert, before insert, etc. It's the same on those predicates.
Any other questions? Yeah.
Are you guys using interview framework? And if you are using interview framework, does the role-level security works well with interview models?
Absolutely. So yes, we are using entity framework. So the only bit of fiddling we have to do is just change the object context to pass through the user ID whenever it does a query, and that's pretty trivial. But apart from that, it works seamlessly. Yeah, I've been so impressed with row-level security. All these features have just worked out the box. They're just magic. They've been really good. Yeah. Okay. Yep. Because Stack Overflow said Angular. No, it's a good question. We get this a lot. Which framework you should use. Yeah, but I think what you got to do is pick a framework and commit to it. At the end of the day, they've all got strengths. They've all got weaknesses. They all use similar concepts. You can get very religious about your frameworks, and people do. But at the end of the day, pick a good framework that's got lots of support, good documentation, good community around it, and go with it. I think that's my opinion.
And because we do quite a lot of projects and all around the Angular side of things, we're getting a lot of reuse between the projects as we're creating assets and conventions. So we have a few projects now that use formally conventions that we built within the Crohn's project, and they've carried forward and been refined even further. So from our development aspect on other projects, it's actually been great. Yes?
Did you use Angular formally or just pure formally?
So the question was, did we use...
Did you use Angular formally? Library?
Yes, that was
Yeah,
Angular formally,
it
the
was Angular
library,
formally.
yes.
And how does that compare to Angular 2?
So the question was, how does formally convert to Angular 2? At the moment, there is a project, a conversion project for Angular 2. It's run by a different person that wrote the original. I haven't seen the status of that at the moment, but at least it's in the pipeline. And there are some changes within Angular 2 that may mean that we don't have to go down that approach. We'll have to see.
Yeah, Angular 2, apparently there is some means to define forms in JSON already. It's actually been baked into it. So whether that's going to be as extensive as Formally or not, we'll see. But to be fair, if you want to spend a little bit of time, you could roll your own Formally. It's not that hard. And we actually rolled something called Tably because we want to do the same thing. We wanted to define tables, you know, in JSON. So we did that, and likewise, that wasn't hard. So yeah, I'd be tempted to have a crack at rolling our own if there's nothing there. Yeah.
Yeah.
My question is more around the analytical side of it. So I see you go from one SQL database to the other.
Yeah.
Is that a SQL database or like column store and that kind of thing, and then moving it to Power BI?
Yeah, exactly right. Yeah. Yeah. Okay, thanks very much, everyone.
Great, thank you.